In this video, we will discuss confidence intervals for the mean when sigma is unknown. Most of the time, the standard deviation of a population is unknown and must be estimated using S, the standard deviation of the sample. When S is used, especially when the sample size is small, critical values greater than the values for Z sub alpha over 2 are used in confidence intervals in order to keep the interval of a given level at a given level. These intervals are taken from the t distribution. To use this method, the samples must be simple random samples, and the population from which the samples are taken must be appropriately normally distributed, approximately normally distributed, or the sample size greater than or equal to 30. Characteristics of the t distribution. The t distribution shares some characteristics of the standard normal distribution and differs from it in others. Similarities. It is bell-shaped. It is symmetric about the mean. The mean, median, and mode are equal to 0 and are located at the center of the distribution. And the curve approaches but never touches the x-axis. Differences. The variance is greater than 1. The t distribution is actually a family of curves based on the concept of degrees of freedom, which is related to sample size. And as the sample size increases, the t distribution approaches the standard normal distribution. The degrees of freedom are the number of values that are free to vary after a sample statistic has been computed. And they tell the researcher which specific curve to use when a distribution consists of a family of curves. For example, if the mean of 5 values is 10, then 4 of the 5 values are free to vary. Once 4 values are selected, the 5th value must be a specific number to get a sum of 50, since 50 divided by 5 equals 10. The degrees of freedom are 5 minus 1 equals 4. This value tells the researcher which t curve to use. Degrees of freedom are denoted df. For a confidence interval for the mean, df equals n minus 1, where n is the sample size. Note, df is not always equal to n minus 1. This is specific to confidence intervals for the mean. The formula for finding the confidence interval using the t distribution has a critical value t sub alpha over 2. Values for t sub alpha over 2 can be found in table F on page 781. Example, find the t sub alpha over 2 value for a 95% confidence interval when the sample size is 22. df equals 22 minus 1 equals 21. We go to the table and find 21 in the left-hand column and 95% in the row labeled confidence intervals. The intersection where the two meet gives the value for t sub alpha over 2, 2.080. When df is greater than 30, it may fall between the two table values. Always round down to the nearest table value. For example, if df equals 68, it falls between 65 and 70, so round down to 65. Other texts may treat this situation differently. Formula for a specific confidence interval for the mean when sigma is unknown. X bar equals t sub alpha over 2 times s over the square root of n, which is less than mu, which is less than x bar plus t sub alpha over 2 times s over the square root of n. The degrees of freedom are n minus 1. Assumptions for finding a confidence interval for a mean when sigma is unknown. The sample is a random sample, and either n is greater than or equal to 30, or the population is normally distributed when n is less than 30. A random sample of high temperatures for 12 recent Thanksgiving days had an average of 42 degrees. Assume the variable is normally distributed and standard deviation of the temperatures was 8 degrees Fahrenheit. Find the 95% confidence interval of the population mean for the temperatures. Here, X bar is 42, S is 8, and N equals 12. Sigma is unknown, so we use S instead, and we must use the T distribution. There are 11 degrees of freedom, so T sub alpha over 2 is equal to 2.201. Then we use our formula and plug in all of the values to find that, that mu is between 36.92 and 47.08. So we can be 95% confident that the population mean for the temperatures on Thanksgiving days is between 36.92 degrees Fahrenheit and 47.08 degrees